In this video, we're going to cover Module 8, Part 4, which is finding the vertices of parabolas and beginning to look at some of their applications. We're mostly going to do that in Part 5 of this module. So in Module 8, Part 3, in that notes section, what we did was we practiced graphing parabolas in vertex form, and now we're going to work with parabolas in standard form and figure out how to find their vertex, because you have to be able to find the vertex in order to graph a parabola. So please make sure you're completing your guided notes as you follow along. So we have here, again, just as a refresher, our parent function, which is f of x equals x squared. This parent function has a domain of all real numbers. Its range goes from 0 to infinity. Its vertex is 0, 0. This vertex is the important point, right? Because that's where my axis of symmetry goes through. And it's where my parabola looks like it's changing from negative to positive slope. In the last video, we took a look at how we shift our parabolas. This k, if I'm adding or subtracting from the outside, shifts my graph up and down. This h means I shift my graph to the left or to the right. And this a stretches our graph or causes it to flip. This is an example of a quadratic in vertex form. hk is my new vertex. But when we're given functions, quadratic functions, they typically look like this. So how do I find my vertex when I'm given a parabola in standard form? That's what this video is going to teach us. So if we have a quadratic function, f of x, I can find my vertex, which is hk, where h is going to be negative b over 2a. That should seem kind of familiar, like the beginning of the quadratic formula. And our k is f of h, meaning I'm substituting in my h into my function to find my k, because that's my y value, so that makes sense. Otherwise, you could memorize this formula, but I never do that. So h is negative b over 2a, and k is f of h. So we're going to start, as always, with example 1 by labeling our ABCs. So I have h is negative b over 2a. So h is negative 8 over 2 times 2. Negative 8 over 4 is negative 2. That is my h. That's my x value of my vertex. In order to define my y, I substituted in. So I've got f of 2, negative 2 is going to be my k. That's going to give me 2 times negative 2 squared plus 8 times negative 2 plus 5. Negative 2 squared is 4 times 2 is 8. 8 times negative 2 is negative 16 plus 5. That's going to give me negative 3. So my vertex of this function is when x is negative 2, y is negative 3. That's going to be my vertex. And once I know my vertex, I can use that to pick 2 points on either side of my x value. In this case, it'd be negative 1 and negative 3 in order to figure out how to graph this parabola. For example 2, I have f of x equals negative x squared minus 9. Note I'm missing my b term. So in this case, a is negative 1, b is 0, and c is negative 9. My h is going to be negative b over 2a. Well, that's just going to be 0. And my k is going to be f of 0, which would be negative 0 squared minus 9. So that's just negative 9. My vertex is when x is 0, y is negative 9. And you could have seen this possibly without going through these steps, because, for example, this parabola is one that's been shifted down 9 and flipped. It's been shifted down 9 and flipped. So it went down 9 and then it was flipped. It's going to look like this. So my vertex would just be when x is 0 and y is negative 9. That's another way to find our vertex if you have the opportunity to visualize it. And the reason this worked so well is because there wasn't a b term. So when I'm finding my vertex, what I'm finding is I'm either finding my minimum or my maximum point. If I have a parabola that opens up, like this one here, where my a is just 1, I have a minimum value. That's the smallest value my y can take on. If it opens down, so it's got a negative in front, so it's been flipped, then it's going to have a maximum value. I've got a maximum y value of 4. So our vertex is helping us find either our minimum or our maximum, and we know it's a minimum if my parabola opens up, and it's a maximum if my parabola opens down. So here's some properties of the graph of a quadratic function. These are always true. So my vertex is going to be hk. H is negative b over 2a. K is f of h, or you could write it as f of negative b over 2a. My x value is always going to be my axis of symmetry. If my a is positive, it opens up. If my a is parabola, it opens down. So if my a is negative, the parabola will open down. So let's practice graphing these quadratic functions. So the first thing we need to do is determine whether our graph opens up or down. For this example here, it is going to open up. Then I find the vertex. H equals negative b over 2a. Here my b is negative 2 and my a is 1. So I've got negative 2 over 2 times 1. That's going to give me 2 over 2, which is just 1. To find my k, I need to find f of h. F of h is going to be f of 1. So I've got 1 squared minus 2 times 1 minus 6. 1 minus 2 minus 6 is negative 7. So my vertex is when h is 1, so when my x is 1, y is negative 7. So this is going to be my vertex. When h is 1, y is negative 7. Then I need to fill out a table. I need 3 points to graph a parabola. But what's really nice is I need 2 points equidistant from my vertex. So I could pick 0 and 2 to find those y values. When I plug 0 into my function, 0 squared minus 2 times 0 minus 6, I just get negative 6. And I know that this is my axis of symmetry. So I find that this is negative 6 as well. So there I have my 3 points. It's always a good practice to state our domain and range. Our domain is all real numbers. Our range is from negative 7 to positive infinity. Let's try this again. I have to find my vertex. I know that this parabola is going to open down because my a is negative, so negative 2, b is negative 4. H is negative b over 2a, so I get negative 4 over 2 times negative 2. 4 over negative 4 is negative 1. My k is f of negative 1. So I have negative 2 times negative 1 squared minus 4 times negative 1 plus 6. That gives me negative 2 plus 4 plus 6. My answer is going to be 8. And of course, my graph is cut off. So we'll extend it. We'll let this be 8. Is that okay? So now I have a point. I need 3 more. I know when x is negative 1, y is 8. I'm going to look at the 2 points next to when x is negative 1, and that's going to be 0 and negative 2. It doesn't matter which point I plug in, but I'm going to plug in 0 because the math is easier. F of 0 gives me a positive 6, and that's okay because remember this is opening downward. And I have my axis of symmetry right here. So that would mean f of negative 2 is also 6. So this is going to be my beautiful parabola. My domain goes from negative infinity to positive infinity, and my range this time goes from negative infinity to 8, and that point is my maximum. My maximum is at when y is 8. For these next two examples, what we're going to be doing is we're going to be taking our standard form quadratic equation, and we're going to be rewriting it as vertex form. And the way we're going to do that is partially by completing the square. So our first step, as always, with completing the square is making sure our a is 1. If a doesn't equal 1, we pull out a factor of a because we need a to be equal to 1. Then we're going to add and subtract this b over 2 squared from our equation. Why do I add and subtract it? Well, because if I add 2 and I take away 2, I've got 0. I really did nothing to my equation. We aren't solving an equation. We don't have it set equal to 0. We're just putting this function into vertex form. So we're going to have to both add and take away from the same side. Then we can factor our trinomials a perfect square and combine the constants. Well, what does this mean? Let's do an example. So let's say I have f of x is x squared minus 4x plus 5. I'm going to go ahead and look at this and see, okay, my a is 1, all is good. Then what I'm going to do is I'm going to add my b divided by 2 squared and subtract my b divided by 2 squared. I still have this plus 5 on the outside. So I've got f of x is x squared minus 4x plus 4 minus 4 plus 5. This part right here, since we completed the square, it's going to factor into a perfect square. Over here, I'm going to combine my terms and get 1. This puts us in vertex form. My vertex is going to be 2, 1. And if you graph that in Desmos or on your graphing calculator or by hand, you would see that this is the case. Let's do another example. This one's a little more complicated. So I have f of x equals negative 3x squared plus 6x plus 1. So if a doesn't equal 1, we need to pull out a factor of a. But I don't have to do it from every single term. I can just do it from the beginning. So I've got negative 3x squared minus 2x plus 1. I don't have to pull out a negative 3 from this because that would change the sign. And you see if I distributed this negative 3 back in, I'd get back to where I was. Now I can add my b divided by 2 squared inside. But the thing is, if I'm adding my b divided by 2 squared, which in this case is 1, within this negative 3, that's really like adding a negative 3. So I also need to add a positive 3 because I have to add negative 3 times 1. That's negative 3. I have to do the opposite of that. So I have to add 3. This is going to factor to negative 3, x minus 1 squared plus 4. So our vertex is when x is negative 1. So when x is positive 1. And when y is 4. In these last two examples of this section, we're going to practice finding the equation of a quadratic function given the vertex and one other point. So let's determine the quadratic function with vertex 1, negative 5, and our y-intercept is negative 3. That means when x is 0, y is negative 3. So I'm going to substitute in my values. I have, here's my y, so f of x, here's my x, and I have my h and my k. So I have -3, which is my f of x, equals a, that's what we're trying to solve for, times my x, which is 0, minus my h, which is 1, squared, minus 5, which is our k. We're substituting in. So I have -3 is a times -1 squared minus 5. So I have a minus 5 is -3. Add 5 to both sides. 2 is a. So the vertex form of this function would be f of x is 2 times x minus 1 squared minus 5. Because my h and k stay the same. Now I want to find it if I have my vertex 1, 4 that passes through x is -1, y is my f of x, which is -8. So I'm going to rewrite our vertex form to help me get all set up. I have -8 is a times -1 minus 1 squared plus 4. I'm substituting in for all my values. -8 is a times -2 squared plus 4. -8 is 4a plus 4. If I subtract 4 from both sides, I get -12 is 4a, so -3 is a. So I would have f of x is a times x minus our h, which is 1, squared, plus 4, which is our k. But this a I now have solved for, so that's going to give us a -3.